Okay, today we're going to finish talking, or not finish, we're going to continue talking about quadrilaterals and parallelograms. Yesterday, you just kind of learned what some characteristics of parallelograms were. Today, you're going to learn how you would actually prove that a quadrilateral, remember, four-sided figure, is a parallelogram. So, what conditions must be true if a quadrilateral is a parallelogram? That's what you're going to learn today. So, ways that we can show that a quadrilateral is a parallelogram. We can show that both pairs of opposite sides are parallel, which you know. We draw a parallelogram in here. Okay. Not a very good parallelogram, but you guys know me. Okay. Both pairs of opposite sides are congruent. Those are two things, then that was by definition, the first one, that we can prove that a parallelogram is a quadrilateral is a parallelogram. Okay, we can say that both pairs of opposite angles are congruent. So these are just things that we had yesterday that we are using to prove. The new part is, though, that we can say that one pair of opposite sides is congruent and parallel. Both things have to be true. So this would have to be congruent and parallel. And then we can say that that is a parallelogram. The next thing we would say is that one angle is supplementary to both its consecutive angles. So if I had angle B, and I said that B and A were supplementary, meaning they add up to 180 degrees, that's not sufficient, okay? However, if I was able to say that the measure of angle B plus the measure of angle C also equaled 180 degrees, then that would be sufficient to prove that that is a parallelogram. So you got to have both pairs. Okay, or we could have said, instead of saying angle B and angle C were supplementary, we could have said angle A and angle D were supplementary. Okay, and the last thing is that the diagonals bisect each other. So where they intersect would have to be a midpoint. So this would have to be congruent to this, and this would have to be congruent to this in order to say that, yes, this is a parallelogram. So let's look at some examples. Can we prove that these are parallelograms? This first one right here, we can absolutely say that because opposite sides are parallel and congruent. This one here, though, so this is a yes, but the second one, we can't, okay? Only one pair of sides is parallel, okay? And then the other two sides are congruent. So that's not enough. Either one pair has to be both parallel and congruent, or opposite pairs have to be, opposite sides have to be congruent, all of them, or all of them have to be parallel, the opposite pairs. So this is a big fat no. Okay. Now when we're talking about angles, this first parallelogram is, or first quadrilateral is a parallelogram because I've got my opposite angles, 70 degrees and 70 degrees congruent, and then these are also congruent because they're marked with the symbol for congruency. Okay, the second parallelogram looks like it might be, a second quadrilateral looks like it might be a parallelogram, but we're going to find that it's not. We're going to add up these, and I wanted to actually make this an 18 instead of a 112. So 62 and 118 is definitely 180. So if we name that angle A and this angle B, those are supplementary. However, we have to have angle C and angle A supplementary as well, and 108 and 62 only adds up to 170. So this is not a parallelogram. All right. So now, in this example, we want to find our value for x, and we are told that this is a parallelogram, which means that the diagonals bisect each other. Continue recording. All right, so I'm going to set these equal to each other, and my stylus broke if you have, well, the battery's dead if you can't tell by my writing, so I typed these in. So 6x is going to equal 3x plus 2. If I subtract 3x from both sides, I'm going to get 3x equals 2, and I divide, x is going to be 2/3. There it is, a dreaded fraction. Okay. Here, I've got a parallelogram again. Told it they're a parallelogram. Okay. So my opposite sides can be congruent. This side is 3x minus 5. This side is x plus 7. They should be congruent. Y plus 6 should equal 2x plus 2. But we can't solve that because it has two variables, so we're going to go with the 3x minus 5 equal to x plus 7. Okay. If I subtract x, I get 2x minus 5 equal to 7. If I add 5 to both sides, I get 2x equals 12, and then x equals 6. Now that I know that x is equal to 6, I can plug that into x for the other equation that I'm going to make with the other sides. So y plus 6 is going to equal that 2x plus 2. We know that x is 6, so we sub it in. And we're going to get y plus 6 equals 12 plus 2. Y plus 6 equals 14. And then y equals 8. So the values for my variables are 6 for x and 8 for y. Here, in this example, we have another parallelogram. We know opposite angles are congruent. It's not going to help us because that means 5y is equal to 5x minus 10. But the other pairs, angle I is x minus 2, angle L is 5x minus 10. Those are supplementary, so I can add them together to give me 180. And here are the steps to solving that. You should know how to do this. In fact, if I were you guys, I'd be pausing this and double checking my work. Okay, so once I go through the steps through solving, I'm going to get x equals 32, and then I can use that fact because these two angles are congruent. So to solve that, here are the steps. Put 32 in for x. 5 times 32 is 160. 160 minus 10 is 150. And if I divide by 5, y is 30. Okay. Last example is we're going to prove that we're given that angle ALN, which is this angle right here, is congruent to angle DNL right here. We're also given that ANL is congruent to DLN. Now, lots of different ways that I can prove that this is a parallelogram. I want to take the easiest. It looks to me like we're setting up to prove that some triangles are congruent. So we can do that. The last piece we need, I've got two angles, is I can say that that side is equal. So I'm going to go with my givens first. Okay, there are my givens. All right, so now we can say that this line is congruent to itself. Okay, and that would be by the reflexive property. So Ln is congruent to NL by reflexive. And now if you look, we've got an angle, a side, and an angle on both of our triangles. So this is going to be angle, side, angle. Those triangles are congruent. Okay. And now that we've got those congruent, we can say there's lots of different things we can do. And in fact, I went for saying that angle A is congruent to angle D, but that actually doesn't give me both pairs of opposite angles congruent. So what I have to say, one of the things I'm going to do is I'm going to say that AN is congruent to DL, and AL is congruent to ND, and that would be by CP-CTC. That would be by CP-CTC. I don't know why I said that. So by CPCTC, I thought I typed that. All right. And then we can say it's a parallelogram because if both pairs of the sides of a quadrilateral are parallelogram, then it is a parallelogram. So we've proved that this is congruent and that those sides are congruent and it is a parallelogram. All right. So hopefully today you learned all of these different ways that you can prove that a quadrilateral is a parallelogram. Have a great day. I know you guys are thrilled because that means you're going to have proofs. I'll see you tomorrow.